Today, we're going to explore one of the biggest mysteries in all of science, dark matter. It's this invisible substance that seems to make up most of our universe, but, well, we've never actually seen it. We're going to look at the evidence for why we're so sure it exists and uncover why this invisible cosmic web is so essential to, well, everything.
Think about this for a second. At this very moment, invisible matter is flowing right through you, through the room you're in, through the entire planet. It outweighs every star, every planet, and every living thing that we can see combined. It's the silent, unseen majority of the cosmos. And this chart really puts that into perspective. Everything we see and touch, everything we're made of, what scientists call ordinary matter, makes up less than 5% of the universe. Just think about that. Meanwhile, dark matter clocks in at around 27%. So we're living in a universe where the vast majority of stuff is completely invisible to us.
All right, so to really start digging into this, we first need to get a clear picture of what scientists are even talking about when they say dark matter.
It's a pretty simple question, right? But the answer really opens up a whole new way of looking at reality. So what exactly is dark matter? In the simplest terms, it's defined by what it does, and maybe more importantly, by what it doesn't do.
So here's the deal. Dark matter basically has two main properties. First, it has mass, which means it has gravity. It pulls on things around it. And second, it does not interact with light at all. It doesn't emit light, it doesn't reflect it, it doesn't absorb it. And that's why every telescope we've ever built is completely blind to it. Now, to really get how strange this is, let's just compare it to the stuff we know. Ordinary matter, that's us, it's made of atoms and it absolutely interacts with light. That's how we see the world. Dark matter, on the other hand, is probably made of some totally new, unknown particle, and its only known way of interacting with our world is through gravity. That's it. Okay, so if we can't see it, how can we possibly be so sure that it exists? It's a perfectly fair question. And the answer is that it leaves behind these huge cosmic clues, evidence of its gravity at work all across the universe. The first big clue came from just watching galaxies spin. You know, in our solar system, the farther a planet is from the sun, the slower it moves. Astronomers expected galaxies to work the same way, but what they found was shocking. Stars way out on the edges of galaxies were moving just as fast as the stars close to the center. This observation just didn't make sense. It flew in the face of the known laws of gravity. If you only count the visible matter, those super-fast outer stars should be flung right off into deep space. The only thing that explains it is a huge, invisible halo of extra mass, dark matter, surrounding the whole galaxy, providing the extra gravity needed to hold it all together. And then there's another incredible piece of evidence called gravitational lensing. Einstein predicted that really massive things literally bend the fabric of space. So when light from a faraway galaxy travels past a huge clump of dark matter, the path of the light gets bent. For us, this makes the galaxy look distorted and magnified, and it lets astronomers actually map out where the invisible mass is. But maybe the most direct proof we have is something called the bullet cluster. This is what happened when two clusters of galaxies collided with each other. The normal matter, all the visible gas, smashed together and slowed right down. But when astronomers used gravitational lensing to see where the mass was, they found that most of it didn't slow down at all. It just passed right through. This separation of visible stuff and the source of gravity is considered the smoking gun for dark matter. So all this evidence does more than just tell us that dark matter is real. It also reveals that it plays this absolutely fundamental role in building the entire universe. And this is really the best way to think about it. Back in the early universe, dark matter formed this kind of cosmic web, an invisible scaffolding. Its gravity was so strong that it started pulling the ordinary matter into these structures, basically giving stars and galaxies the seeds they needed to grow. Without that framework, the stuff left over from the Big Bang would have just stayed too evenly spread out. The gravity from ordinary matter alone just wasn't strong enough to pull everything together and form the galaxies and clusters we see today. In a very real way, we probably wouldn't be here without it. Okay, so we know it's there. We have a good idea of what it does, but that just brings us back to the biggest question of all. What is it? What's it made of? And trying to answer that is one of the biggest missions in all of physics today. Right now, there are two main ideas. The leading theory is that dark matter is some kind of new, undiscovered particle that barely ever interacts with our worlds. But there's a second, more radical idea
maybe there are no new particles. Maybe our theory of gravity is just wrong, and it needs to be changed when you're talking about huge cosmic scales. And you can bet people are looking for that particle. It's this massive global effort. Scientists have built these enormous detectors, often deep, deep underground to protect them from other radiation. They're trying to catch that 1 in a billion moment when a dark matter particle might just happen to bump into a normal atom. So far, nothing definite has turned up, but the search goes on.
Figuring out what dark matter is, it's more than just solving some cosmic puzzle. It's really about understanding the basic nature of our universe and, well, our place in it. Let's just come back to this number for a second, because it's pretty humbling. All of human history, all of our science and art and exploration, it's all been built on understanding less than 5% of what's actually out there. This discovery really forces us to accept a pretty profound idea. Our whole perception of reality is dramatically incomplete. We are living inside a much larger, invisible universe that's working by rules we're only just starting to figure out. You see, solving the mystery of dark matter won't just change physics, it will change our fundamental understanding of reality itself. And it leaves us with this final amazing question. What else is waiting out there for us to discover in the other 95% of our universe?